Docker containers give our applications an isolated environment in which to run. In some cases, our applications will require multiple containers to function properly. A lot of applications ship with companion services or sidecars that run in separate containers. Imagine a web application that uses Redis for caching. The application would require two containers on the same network so that the web application can interact with Redis. Just like containers are isolated, the networks that they run on can also be isolated. In our hypothetical example, no external application needs to talk directly to Redis, so only the web application needs access. This can be done with Docker networking. First, let's discuss the basics of Docker networks. Docker by default runs 3 networks on the Docker host. We can see these networks listed by running the command docker network ls. We see that 3 networks are listed. Whenever we launch a container, we can choose one of these 3 networks. The first network that we'll talk about is the default network, which is called the bridge network. Without specifying a network at launch time, this is the network that containers will run in. Any container running on the bridge network cannot be accessed outside the Docker host unless a port is mapped to the Docker host using the -d parameter in Docker run. Let's check out the bridge network. Since I'm running on a Mac, I will need to SSH into the Docker host using Docker machine SSH. Now we're SSH'd into the Docker host. Let's run ifconfig to view the available network interfaces. Docker 0 is the bridge network. We can see that our Docker host has a 172 IP address. Any container launched on this Docker host will be on this network unless specified otherwise. These IPs can only be accessed from our Docker host, and so when I exit back to my Mac shell, I am no longer on the default bridge network. The next network is the none network. The none network is just that, nothing. Let's launch a container using this network and take a look at its network interfaces. We'll use the Hello O'Reilly HTTP application from earlier in the course. To launch a container on a network other than the default bridge network, you can use the net option and specify the name of the network to use. Next, we'll use docker exec to start a secondary interactive shell process inside our new container, which we've named NoNetworkApp. Now we're inside the container, and we can once again run ifconfig to see the network interfaces available. And of course, in this container, only the local loopback network is available. This means that we cannot access anything via the network outside this container. The third network is the host network, which is the same networking that the Docker host uses. Running containers on the host network means that we don't have to expose and map ports, because they will be bound on the Docker host directly. Using the host network eliminates a lot of isolation that the bridge network affords us. This means that if we run 2 applications in containers that expose port 8080, there will be a port conflict, since they would both be bound to the same host. Let's run our Hello O'Reilly application on the host network and take a look inside. Now that we're inside our host network container, we can run ifconfig again, and we should see the same interfaces that we saw when we ran it on the Docker host directly. We can see that this container not only has Docker 0, or the default bridge network, but it also has the other network interfaces that the Docker host has too. Let's try running the same image in another container using the host network. We'll omit the -d so that we can see the output immediately. As we can see, the Ruby application failed to start up because the other container running on the host network is using port 4567. This is a major disadvantage to using the host network for containers.